Hello. So what are the advantages using multi-stage rocket is just each stage can use different type of motor, and the total weight of the rocket is reduced as the rocket rise. The third advantage is multi-stage rockets has a bunch of thrust. That fuel causes thrust, and so when it drops to another stage, there are more thrust in the fuel, just keeping burning. And the main advantage also here is that it drops useless weight and goes faster. So that is advantage. Okay. So okay, these questions are not related with the topic which we are talking. Anyways, let it be there. So we call multi-rocket reduces the fuel consumption. How it can happen? For that, maybe multi-stage rocket on each height of about 100 kilometer gets rid of the first stage, and then the mass of the rocket is reduced. In each stage, the load on the rocket is reduced, and hence the consumption of fuel is less in multi-stage rocket. This is a simple answer. Anyways, what are space debris? These are, you see, multiple of stage debris are there in the space. These are kind of stage debris because of the presence of such stage separations, and there are also some kind of small asteroids and meteoroids which are just running or orbiting around the Earth. So these are kind of space debris. The more there is some space in between Saturn and its belt. Near to Saturn belt, we can find a number of meteoroids and asteroids. That is called the asteroid belt, we call. Like that, near to the Earth's surface, because of those discarded mass or discarded skeleton of the structures, we can find a number of debris like this. Not only this, there are some satellites which are decayed after a certain period. Those who lost their fuel after a long period of time, they are also simply orbiting around the Earth. So which are called also space debris. So that is what. So how we can collect space debris? There are mission called remove debris mission. That remove debris mission, this is the method how people try to remove debris from space. They are collecting it with the help of some net. There are some space launch vehicles which are launched to particular areas which is considered as areas with concentration of space debris. So they can collect it like this. Okay. And sometimes, okay, a remove debris mission aims to tackle the problem imposed by space debris. So remove debris satellite launch out and net and traps. You see there are traps and nets are there which are collecting debris from the space. Okay, that is kind of remedial action actually. The net is not retrieved again by the satellite or the ISS, International Space Station, but it is nudged in the direction of the Earth, allowing it to fall back towards the Earth's surface. So it collects and then brings all these debris to the Earth's surface. So that is kind of remedial mission to collecting space debris. So let's go to the previous slide, which we have stopped here, because I transferred from this slide to there. in order to get more information. So simply this staging is just jettation of self-contained propulsion units known as stage after the consumption of their propellants, a crucial technique for removing the mass ratio of space transport system, not using an environmental engine actually. So the first theoretical analysis of staging was done by actually the well-known Russian scientist who developed the rocket equation known as Konstantin Tsiolkovsky. So to achieve higher final velocity, by the rocket, the launch vehicle must be multi-staged and remove some of the structure that is not longer needed during the flight. So this is the method. So as you see, this is the full structure which is launched. Okay, so that is first stage motor ignited at the very beginning. And then when it reaches to here, the first stage separation will take place. And this mass will be fallen down like this. This is the method, the way it is falling down. And then the next stage will ignite and continue to move. Look, this is second stage. And the third stage or firing stage means the one with having the payload. So this stage will also go to somewhere and it discards this structure like this, firing drop. And then what is left? Only the second stage motor shut down and the second stage separation take place. Then after the third stage will start to go up. So third stage motor ignited at full power, beginning of third stage program. So this is actually the method how we can create staging and the stage separation. So what we have discussed previous is all the same. So staging are like serial staging, parallel staging, serial parallel staging, and single stage case. Okay. And stepper. So the serial staging is simply just, as you know, how we can connect a serial connection. So that is having stack on top of each other, one on the top of each other. In the parallel, in sidewise mounted means sustainer and the booster stages are connected in side by side. And the serial parallel is combination of the two. And another staging is single stage. Throughout the process, there may be only one single stage. Okay, one single stage. That means even the structure with no use also be carried with that kind. But this is not an efficient method. Yeah, so these are some of the serial or tandem stage, the parallel staging, and the combination of the two. Okay. Yeah, this is what we have discussed already. Already we discussed it. So this is Saturn Saturn V moon mission, or the Saturn V moon rocket flight mission. Look, it is launched from somewhere, and then when it is launched, it is not launched, but at the first stage separation, you can find 972 meter per second at this point. And then look how the velocity gain obtained. As the separation of first stage, which is separated at 71,526 meter altitude. So during that time, the velocity of the rocket is 2.972 kilometer per second. But when you arrive to the separation of the third stage here, okay, separation of third stage, you can find 4,489 meters per second. So high speed is gained here. And then that is done at 127.86 kilometers away from the Earth. So third stage separation takes place. And so on. So this is kind of information how we can see. So initial mass was 2,283,034 kilogram initial mass. As separation of first stage, you can find 481,441 kilogram only. And at the final, after the separation of second stage, the third stage left is 118,420 kilograms. So this is the amount of mass reduction and the amount of velocity gain what we are checking here. Yeah. Allah? Which class he has get? Sorry once. بالبلد؟ يتو. ይቺን እስቲ ቀስ ብለን እናውራት አይደል ያላቅ
ተማሪ ሰብስቦ አዘሩ ተማሪ ሰብስቦ ከሌት ይላል ከተማ ታገኛለ ድሮ እንግዲህ ይብዛን መስል እኔ ሰርቻለሁ አይደል ፕሮጀክት እንኳን
ጨርስና እንደውም ዲስከስ እናደርጋለን። Okay. So this is the parallel staging as we have discussed earlier. Serial parallel staging also there. Single stage only. Single stage to orbit, or we call it as SSTO. So this type vehicle reaches to orbit from the surface of the body using only single propellant and fluids without expanding or without discarding the skeleton. So fully reusable vehicles that can fly into orbit and return to land site like airplane are ultimately use this type of staging. Not staging, but just a single stage only. So the best example is the Venture Star, which is called the SSTO type. Okay. And another important thing, once we start to talk about staging, then the ascent trajectory is one of an important thing. Look, what are the ascent trajectory? We may have a particular point of launching, and once after launch, the spacecraft will go some trajectory path. So that trajectory should be designed at the very beginning. Okay, so there is some atmospheric flight that our aircraft is flying through the atmosphere, and then there is some stage one may be separated. Okay, separation of stage one may take place, and then the firing trajectory will take place. So at the firing trajectory, there may be some thermal flags that happen because of various atmosphere. So there are. It is called far safety. This region is called the far safety regions, or ground station control may take place for the checking the locations. Debris fell out maybe because of the some thermal firing case. There may be breakdown of those debris may fall down around, and then there is crust arcing. This region is called crust arcing, and then the orbital insertion will take place next. So dropping of stage helps in minimizing total weight and accelerates the rest of vehicle much faster. As a result, less propellant consumption is required to reach a desired orbit. So when we call ascent trajectory, that gives you this full trajectory. So space launch vehicle deliver payload into orbit by moving so fast that they can overcome Earth's gravity. And after they reach the desired altitude, they release the payload at very high speed. So payload separation will take place. Almost all rocket-powered launch vehicles are launched vertically from the ground, and they usually try to get out of the dense atmosphere as soon as possible, since the atmosphere increases drag loss. When the ascent is too steep, energy is sent to lift the propellant to high altitude, which causes gravity losses. Therefore, the launch vehicle turn down gradually to have some almost horizontal acceleration after leaving the atmosphere. So it will not go very steep hill. It is not go in the direct vertical position. It will give some bend. Okay, that's what you call. So look, this is the Earth's surface. From some particular position, the launch vehicle will be launched from here. Sometimes, you know, the launch vehicle we may send to some Earth's outer areas like polar regions to launch it, and then it will accelerate around the Earth's apex and perg points. There are apex and perg points. So on that, it gains velocity at the very beginning. After one rotation around the Earth, it gains some velocity and then leaves the Earth's surface. So such kind of design also there. So this is the point where an appropriate launching point, and then it enters into the Earth's orbit like this. So ascent trajectory depends on the location of launch site. So launch site is very important, because there are full of gravity areas like gravitational attraction 9.81. That is not an appropriate point. We search for areas with less gravitational. Okay, yeah, you can go. Okay, so propulsive, gravitational, and aerodynamic forces acting on the vehicle during flight. So for safety and operational constraints on the trajectory and the parameters of the injection or with that vehicle rise to achieve. So we can search for an appropriate trajectory and appropriate launching site. Okay. So a small change in the ascent trajectory can have significant effect on the payload mass that can be delivered into the space orbit. So we have to think of how to optimize that the ascent trajectory. The second thing is the spacecraft. Still what we are talking is a space launch vehicle. Okay, spacecraft is another. So spacecraft is just a vehicle, which is just a machine designed to fly in outer space. Outer space means space beyond the atmosphere. So a type of artificial satellites, spacecrafts are used for a variety of purposes, including the communication, Earth observation, meteorology. Means this meteorology is just accurate measurement condition for the navigation purpose, for space colonization purpose, for planetary exploration, and for the transportation of human and cargo to space. For that purpose, we need a spacecraft. So this is a spacecraft, the Soviet Union first spacecraft, which sent by the first one in 1961. The Vostok capsule, we call it, is capsule called the Vostok capsule, and which is sent with Yuri Gagarin. Okay, Yuri Gagarin left on April 12, 1961, with the capsule called Vostok. So that is one of the spacecraft sent to the space and come back to Earth. So now this is not reusable type of, it is not expandable. So spacecraft can be piloted like space shuttle or be unpiloted. Sometimes we have unpiloted spacecrafts. Another is in 1968, the Apollo. If you read some books, there is Apollo mission. So Apollo in 1968 was the most famous spacecraft in the world. So Apollo capsule were the one who helped landing human on the moon. So the first mission of human mission to the moon was accomplished with Apollo. So this is done by the American in collaboration with the American and the Russian scientists. And the mission was initially generated by the American president, John F. Kennedy. He gave mission to the American scientists to explore land within 10 years. Okay, in 1959, he gave order to the American scientists in order to land on moon, but they accomplished it within 9 years. So that's why this Apollo is the first mission to land on moon. So depending on its application, the spacecrafts can be classified as interplanetary, manned or unmanned, or transsolar vehicle. Okay, these are classification of spacecraft. And some of the primary function of spacecrafts are just orbit insertion purpose and orbit change maneuvering and the space flights. So these are the main functions and the secondary function. So this one is the primary function: orbit insertion, orbit change maneuver, and space flight. The secondary function of spacecraft is for attitude control, spin control, momentum wheel and the gyro unloading and stage separation. So these are secondary purpose. So in order to execute these functions, a spacecraft can carry a number of rocket engines. Okay? So pulsed small rockets with short bands of thrust are also being used for such condition. Okay? So these are crewed spacecrafts that Vostok 1. Okay. The first spacecraft, which is sent by Yuri Gagarin. So look, this is Vostok with its dimension. Mercury 1961 is one of the American spaceship, which was a cone-shaped capsule that carried just one person. And 3 weeks after the Soviet Union launched again the Yuri Gagarin into space, and astronaut Alan Shepard becomes the first American on suborbital flight. Again, another astronaut, John Glenn, reached orbit in February in 1962. So these are some of the histories. Okay. Yeah. Again, German also come into space race in 1965. So this is some of the German United States capsules or spacecrafts. Again, Suez 1967 is one of another So which is sent into the capsule still ferries cosmonautics back and forth to the International Space Station. So it is still working. So the spacecraft was first deployed in 1967, and the Suez of today looks much, actually, even in the very short, I don't know, within 1 year, they also launched another Suez version. So three main parts of the Suez are the descent module, the orbital module, and the propulsion module. So another is the Apollo mission to the moon. Okay, this Apollo is the first mission to land into moon by human being. So which is done in 1968. And the spacecraft were designed to carry even more astronauts, including 12 people who have worked on the lunar surface. Again, many types of spacecrafts are there. Okay. Again, Space Shuttle in 1981 is also another. So in between 1981 and 2011, there were 5 different shuttles and 135 crewed missions have been performed. So this is the blessing of the space race. Another, in the miscellaneous type, we stated the space shuttles, the space crafts, and the miscellaneous missions. So miscellaneous missile is one of that miscellaneous component. So in military terminology, missile is a guided airborne range weapon capable of self-propelled flight, usually by the jet engine or rocket motor. So missiles are actually most of the time for military application. It is different from rocket because missile contains some intelligent system in it. The guidance and uh, uh, the guidance in some systems are there. Okay? That helps missiles to detect the target and hit the target. It can check the proximity of the target. For that purpose, missiles have some 5 important components: the targeting system, the guidance system, the flight control system, engine, and the warhead. So this warhead is the one which causes distraction to the target or the enemy target. The engine is the one which provides propulsive force. The flight system helps to control its movement, directional movement, like the fins and the wings, which helps to control the pitch, yaw, and roll motion of the missile. And the guidance system, the control and the guidance system helps to detect the target, to initiate the warhead, and to check the proximity and the target also. So this is all about missile. So these are some of the missile types. The Pragryan air-to-air missile type. Actually, missiles can be ground to air, surface to air, air to surface, air to air, surface to surface, or maybe it can be intercontinental ballistic missiles, or it can be tactical missiles. Okay, so ICBMs is the intercontinental ballistic missile which we use. So missiles can be guided and unguided. So unguided missiles are categorized as like rocket, but the guided missiles are called the missiles. And there are missiles which is used underwater. We use some missiles underwater. We call them as torpedo. And the guided missile powered along a low or level flight path by air-breathing jet engine, which is called cruise missile. So this missile propulsion and control and guidance can be categorized into strategic missiles, cruise missiles, ballistic missiles, which is dependent on the Mach number, which the Mach number means, that is the ratio of objective speed to sound speed. So based on that, we categorize them like this. Anyways, this is the type of missiles: air-to-air missile, air-to-surface, surface-to-air, anti-ship, anti-tank. Again, when we come to ballistic missiles, short-range ballistic missiles, medium range, intermediate range, intercontinental ballistics. That is based on the distance it covers. Okay. For example, this intercontinental ballistic missile will flow 5,310 kilometers. That means, as we know, the radius of the Earth is about 6,700, like that. Radius of Earth, 6,700. So this can cover almost the radius of the Earth, you see. So this can attack from one continent to another. Okay, 5,300 means it is long range, so it is called intercontinental ballistic missiles. So this is all about, actually, anti-tank guided missiles, we call ATGM, which can be guided by laser, which can be guided by television or wire guidance system. So many guidance systems are there. Anyways, we don't give much emphasis on these areas. So this is the way how we can construct a given missile or rocket. Look, solid rocket booster. This is a booster which helps to carry the rocket to somewhere. You see, there are here boosters. So how these boosters are constructed? Okay, you have various components of the booster. Okay, these are propellants at every stage. Okay, you can see the cross-sectional area of each stage. And these are also the propellant, solid propellant types. Okay, cross-sectional area of solid propellant types. And this is the propellant geometry, which, okay, and this is the assembly of all these things. So this is all about today's discussion. If you have any question, you can ask. Hello. Hello.
በእኔ በኩል የለም ዶክተር።
ሰው በአብዛኛው የለም፣ ሁለት ሰው ብቻ ነው ያለው።
በእኔ በኩል ጥያቄ የለም።
እሺ ኦኬ እሺ። ስለዚህ በዚህ ይበቃል ዛሬ። ሜቢ አንድ ጊዜ እንደዚሁ ባገኛችሁ፣ አሁን ሰውም ስለሌለ እንውጣና እንትን እንላለን። ኔክስት ላይ ስለተለያዩ ፕሮፔላንቶች፣ የሮኬት ፕሮፔላንቶች እና የእነሱን ካራክተሪስቲክስ እናያለን። ዘን አፍተር ዊል ፊኒሽ አወር ክላስ።